Hi, ladies and gentlemen. We are going into more reviewing for your final. We are going to work on Chapter 2. So if you have your handy dandy little review, we're going to start at Chapter 2. So I grabbed it because the first question says, is the graph at the right of function? So we're looking at this graph over here. It kind of looks like an S, or at least the best S I could make using whatever program I was using. It doesn't look great, but it asks if it's a function. Well, to tell if this is a function, we need to look at the vertical line test, the VLT, vertical line test. The vertical line test says if I can draw a line that's vertical, obviously called vertical, and it can touch my shape, whatever shape it is, in more than one spot, then it is not a function. Now, if I had maybe like a parabola and I drew vertical lines, see, those only hit in one spot, so that would be a function. So to answer this question, so number one, is that a function? No. And not only do we have to say no, but it says why or why not. So we can just say that it fails the VLT, or vertical line test. Okay, number two. Number two is asking if this set of numbers is a function. So this set of ordered pairs, sorry, not just numbers, ordered pairs. So what I'm going to do is go through and highlight the x's. And the reason why I'm highlighting the x values and not the y values is that in order for a list of ordered pairs to be a function, it has to be 1 to 1, meaning each of my x values can only go with one y value. So I have to make sure I don't reuse. So I have 0. Do I have 0 any other times? Nope. I have -1. Do I have -1 any other times? Nope. I have 4. Do I have 4 any other times? No. -3? No. 7? No. So it looks like all of my x values are only used once, so that makes it a function. So is it a function? Yes, because each x value goes with only one y value. Okay, 3. Now we finally get to do some math. We have a line with a slope of 2/3 going through the point -6 and 4. Get some contrasting colors going on here so we can see what's going on. Okay, so I am going to start out by making this in point slope form. So the point slope form says y minus y1 equals mx minus x1. So this 2/3 is obviously m, and y and x get to stay letters. Everything else gets replaced by a number. So what do you think is going to go in place of y1? Well, hopefully you could tell by the color that I picked up. It's going to be the y value of my point. So it's minus that number. Inside the parentheses, it'll be the x value of my point. So it's going to be minus -6, but minus -6 is going to change that to +6. So now that I've got this set up in point slope form, I probably should make sure I read the directions. Okay, it says it wants it in slope intercept form. So that's not the form I'm using, but I can change it. So to change it to slope intercept form, I have to get the y by itself. So I need to distribute this 2/3. So I'll keep the y minus 4. 2/3 times x is 2/3 x. 2/3 times 6. Okay, well, to do that, I would multiply that and I get 12 divided by 3. So that is 4, right? Okay. Then continuing to get the y by itself, I would add y equals 2/3 x plus 8. And that would be my answer. And that's in slope-intercept form. I know that because the y is by itself. Next, on number 4, it says rewrite. Okay, so I've got, let's go, -4, 10, and -6, 15. And it wants this in slope-intercept form again. Okay, so in order to have slope-intercept form, I need the slope and the y-intercept. I don't have either of those. So let's find the slope first. So remember to do slope, you do y2 minus y1 divided by x2 minus x1. So to find my slope, I'm going to start with 15, and I'm going to subtract the y value from the other point, which is 10. And I'm going to divide that by the x's. And notice that since I started with this 15, that's the first point I started with, then in the denominator I have to start with that same point. And it is minus, but in this case it's minus -4, so that makes it +4. So if I continue on in this vein, 15 minus 10 is 5, -6 plus 4 is -2, so my slope is -5/2. And 5 doesn't divide by 2, so that's as simplified as it can get. So then I'm going to do the same thing with point slope form. Okay, I've got my slope here. Now I just need a point. And it doesn't matter which one. I've got 2 points, and it doesn't matter which one. So I'm going to pick this one just because it has smaller numbers. So remember that y stays and x stays, and everything else gets replaced by a number. So my slope was -5/2, and I had y minus y1, so minus 10, and in the parentheses x minus x1, so minus -4 gives me +4. Distribute, so y minus 10 equals, okay, the lights went off, but let's see, how can we make this situation better? There we go. Okay, -5/2 x, and let's see, -5/2 times 4, so that's going to be -20/2, so -10. Please don't think that that's a pattern, that those are always going to be the same number. That's just a fluke in these two problems. So -5/2 x plus 0. Okay, so I guess I could have written it as just -5/2 x, and it would have a y-intercept of 0. Okay, 4 is done. So now on to 5. 5 says, rewrite this shindig, 12x plus 8y equals -24 in slope-intercept form. Well, to get slope-intercept form, I need to get the y by itself. So the first thing I'm going to do is move my x term. It's positive, so I'll subtract it from both sides. So I've got 8y equals -12x minus 24. Then it looks like to get the y by itself, I need to divide by its coefficient of 8. So here we go, some division. Okay, now 12 doesn't divide by 8 nicely, but I can see they're both even, so I could divide them by 2. That would give me 6 and 4. 6 and 4 are both still even, so probably I can divide by something bigger than 2. Let's try 4. If I divided by 4, I'd get -3/2. Yep, that will work, because then I don't have any, what am I thinking? Nope. Then it's as simple as possible. That's what I'm thinking. Okay, and then 24 divided by 8 is 3, and that's negative, so -3. All right, that is now in slope-intercept form, and we know that because the y is by itself. So that was 5a. Now on to 5b. It says write an equation parallel. So parallel means that they will have the same slope. Okay, if I look at this equation, my slope is -3/2. And then it wants it on this one to go through the point 8, -7. So, same thing, I have a point and I have slope, so I'm going to use point slope form. Okay, now if it had said perpendicular, remember you would have had to flip this slope over and change its sign. Flip it over and change its sign. But since it said parallel, we just use the same slope. Okay, y, not m. And I don't have any white out, so that's just going to have to stay there. That should be -3/2. Y minus y1, so minus -7 is going to give me +7. And x minus x1, so -8. And then it didn't say, did it say write an equation parallel? Okay, so it just said write an equation parallel, so actually we could probably be done, but since all the other ones have been in slope-intercept form, I'm going to go ahead and change this one to slope-intercept form as well. So y plus 7 equals -3/2 x, and then I have -3/2 times -8. So -3 times -8 is 24 divided by 2. Negative times a negative gave me a positive. 24 divided by 2 is 12. Make sure you're checking my math as we're going, because I am just doing this on the fly and I do make mistakes. Not very often, but you know, I'm human. So 12 minus 7 is 5. So it looks like I've got y equals -3/2 x plus 5. Okay, 6, make a scatter plot. Okay, so I had a little note to myself that I needed a graphing calculator, and so I grabbed one. Hopefully you have one too. So here is for number, no, not 7 yet, 6. Number 6, we need to make a scatter plot. So remember, to make a scatter plot, we have to have our plot 1 on. So the first thing we're going to do is hit y equals, and go up here to plot 1 and highlight it. If yours was already highlighted, you could skip that step. You don't have to do it. But if yours was not highlighted, go ahead and hit y equals, up to plot 1, enter, back down to make sure that it is highlighted, just like this. Now we need to enter all of our data. So here's our data, hours of off-task screen time and test score. To enter data, we are going to press stat. Stat is 2 to the right of your green alpha button. So press stat. Then we are going to hit enter to edit. Now, if you've got some stuff in here, you can go up, hit clear, and back down, and it will all disappear. Same in both, clear and back down. Or if you just want to get rid of one at a time, like if you had a bunch of numbers in there and they were wrong, you can just hit delete to get rid of one at a time. But if you are up here, never, ever, ever hit delete, because it will delete your list. Okay, so we're going to enter our numbers: 0, 0, 1, 1, 1.5, 1.75, 2, 2, 3, 4, 4.5, and 5. Okay, list 2. We've got a 100, 94, 98, 88, 92, 89, 75, 70, 78, 72, 57, and 60. And we do, when we are done, want to make sure that our ends line up at the same place and we don't have an extra number in one column or the other. So make sure that that's happening. Now, once your data is in and your plot is on, you can hit zoom at 9, and it will give you a lovely little scatter plot. So we need to make a box and draw that lovely little scatter plot. Oops, that's not a great box, Mrs. Black. Oh well. Okay, so to make this scatter plot, looks like we've got one here, one here, one here, one down here, a couple down here, over here, here, and there, and like there. Yeah, good enough. Okay, so then it says, make a scatter plot and find the line of best fit. Okay, so the line of best fit we find by going back into stat, and we go over to calc, and then it said line. So which one of those do you think we're going to use for a line? Hopefully you know it's 4. And then we're going to hit enter. So it always starts with y equals, and then instead of putting a, you're going to put this whole big number. So y equals -7.907200055 x plus, so see it was y equals a, which I put in, followed by an x, plus, and then I put in my b, which is 98.05086785. Okay, so hopefully you wrote all that down on your little paper. Okay, so line of best fit, cool, but let's make sure that it actually goes through our stuff. So in order to do that, we can make our calculator switch it over. To do that, we press y equals, then you go to vars, which is right next to the clear button, down to number 5 for statistics, arrow right 2 times for EQ, and hit enter, and then it types that all in to y equals for you. Or you could just sit here and type all of this stuff into y equals if you can't remember those steps. You already have the equation, so you can just type it in. And after that, we hit graph, and let's see, did it go through our information? Yeah, it did. So let's grab this and go, okay, it went through about like such. Everybody agree? It's about where it went. Okay, so then it says, make a scatter plot, check. Find the line of best fit, check. Describe the correlation. That's something we haven't done. Describe the correlation. Okay, using such words as positive correlation, negative correlation, or no correlation. Well, if we look at this going from left to right, do you see that they kind of go down? Okay, so that tells me that our data has a negative correlation. If it had been going up, it would have a positive correlation, or if it had been all scattered throughout and no, like, see how they're kind of clumped together and they kind of go downward? So that's a negative correlation. If they had been clumped together and going upward, that would have been a positive correlation. And if they would have just been scattered throughout and not looked like they were all going in one general direction, that would have been no correlation. Okay, and then our last one, number 7, yay, the lights came back on. We are going to graph negative 1/2 absolute value bar x plus 3 plus 5. So A says we need to find the vertex. So to find the vertex on one of these value graphs, you always do opposite of the inside, comma, outside stays the same. So I'm going to look at inside and I'm going to use the opposite of that. So it says 3, we're going to do negative 3. Then the outside or after stays the same, so 5. So my vertex is going to be at negative 3, 5. So I'm just going to plot some stuff on here. So I've got some stuff to do. Okay, so negative 3 up to 5, there's my vertex. Okay, now my normal pattern for growing for absolute value, let me move stuff around. My normal pattern for growing is over 1 up 1, over 2 up 2, and over 3 up 3. But I've got this negative here. This negative means that I've got a reflection over the x-axis. Okay, so what that is going to do is take all of these ups and it's going to change them to downs. Okay, I also have this 1/2. That is a vertical stretch or compression. Do you remember if it's a stretch or a compression? Hopefully you remember that if it's bigger than 1, it would be a stretch. But since this is not bigger than 1, it's a compression. So I'm going to multiply all of these by 1/2. So I will go down 1/2, 1, and 1.5. So I will still go to the right 1, down 1/2. And I do the same thing on the left side as well. To the right 2, down 1. Oh, I missed 3, didn't I? Well, get it close. And right 3, down 1.5. Hopefully your graph is looking a little bit better than mine. Okay, so this is going down because it's reflected. It looks a little smushier than normal because it's compressed, and it had a shift left 3 and a shift up 5. Good luck on the rest of your final preparation.